In this video, we're going to take a look at critical values, in particular critical values that are associated with normal distributions. So a critical value, and I may call it a critical z-value at some point in time when we're specifically talking about a z-score. We will talk about other kinds of distributions in the future. So we'll talk about t-distributions and chi-squared distributions, f-distributions, and you can have critical values for these, for those as well. Those critical values you should think of as having a similar feel to what we talk about here. So try to, as you think about this, think about what that might look like in another distribution. All right, so a critical z-value is a z-score that separates likely values from unlikely values. So we use a notation with z with a subscript of alpha. This is a z-score with an area of alpha to its right. So we want to find that z-score that has an area of alpha to its right. So if we wanted to find a critical number associated with alpha equals 0.025, and we knew that our distribution was a normal distribution, then really what we want to do is think about this normal distribution. We want to know what is this z-score with 0.025. That is, what is this z-score that has an area of 0.025 to its right. So we're going to take this and we're going to go to StatDisk, just like we did in our last video. However, when we have an area, StatDisk wants an area to the left of the value. So the area to the left of the value is 1 minus the area to the right. And so for us, that area to the left, that's 1 minus 0.025, 0.975. So that's not our answer, but that's what we're going to take over to StatDisk. So there's an area of 0.975 to the left of the value that we want. So here I am going to choose analysis, probability distribution, and I will choose a normal distribution. In the future, we might use something like a student t-distribution or chi-squared or an f-distribution, and we would use an area to the right or left to find our critical value. So cumulative area from the left is 0.975. And we evaluate, and it spits back a z-score. If we round to the third decimal place, that 9 would round up to a 10, so we'd carry the 1, and so we'll round to 1.960. So z with a 0.025. This critical value, that z-score is 1.960. That is the z-score that has an area of 0.025 to its right. It separates the top 2.5% of values from the lower 97.5% of values. All right, in the next video, we're going to continue talking about normal distributions, but we are going to look at normal distributions when the mean is not 0 and standard deviation is not 1. We will jump straight into an example where we do that. All right, we will talk to you then.